Sam, I've got a question for you. We've talked about the transition from Ford Research's free compute cluster, which was obviously needed for testnet, and we're transitioning away from that toward a Hyperbeam mainnet. What happens on day one? What are people going to notice that's different the day that that free compute cluster is no longer around? Will there be any difference? Will there be a massive difference? Help me picture it in my mind.
Jesse, I was about to say, well, we're already long past day one. When you open up Wanda, you're using Hyper-V nodes. But then you said the free compute cluster is dead. That's actually not the plan. What we observed is, well, why did we give people free compute? That's because we like people using AO, right?
Mm.
And we're not the only people. Every project that, or at least many projects, that want their users to have a nice experience would be perfectly happy providing infrastructure. But at the same time, you don't want that infrastructure to be centralized. And so what we've built is a device in the system. There's a device for that. Basically, there's a device for everything.
Yeah.
Yeah. A device in the system for routing. So you send a request to a node that Forward Research runs. This is what's happening in the background if you use LegacyNet now. And Forward Research's node then keeps a list of routes to other peers that it should ask to actually perform the computation on behalf of the user. And there's two areas here where you might want to apply payments. So you could say, okay, to use the Forward Research cluster, everyone has to pay by default. But that would limit the usage. Like if you went to Bazaar and you had to you had to pay to see your balance, for example. This would be very annoying to people. And so what we can do is we say, okay, you can offer, we in this case could subsidize some free access to some certain proportions, and you can add a device. You can build your own even that allows you to decide how you should adjudicate who to give the compute to and who not to. This can be done by balances or by call it friends and family mode, where you keep a list basically of the if it's for your own company's internal use or something like this, you can limit it like that. All sorts of different ways. Well, it's just generally programmable. You can plug in whatever you like to serve that role. Yeah. So we can decide, okay, we want to give some amount of free compute, but not a ton. And then downstream, we can pay the providers. And so at the moment we're running the push nodes because there's, you believe it, we started with 12,000 CPUs. We're down to just a handful of different nodes running Hyper-V. That's radically more efficient than the LegacyNet system for reasons that we've been over quite a few times now, I'd say. So they're just much more efficient, but over time, we want to allow people to register their own nodes to this router. And then they can take part in the computation, and the router device has basically a sort of satisfies constraints, I believe is what it's called in the code, but a mechanism that allows us to say, hey, who should be able to register? And in our case, it's okay, people running inside a TEE should be able to register, and they should be using this build version and this firmware version on the hardware itself, and this operating system, and all the rest of it. So the router operator can then say, okay, I want these people to be able to register. I'm willing to pay them this much for the compute. And the users, I will subsidize that much compute. And this way, you can allow decentralized computation and still allow teams to subsidize usage of the system. And so our plan from here is basically to, first step, get people providing that computation from the community. It's a question of how much computation really is it at the moment? So is it enough to pay people? It's just so much more efficient. It's not really, you can certainly register today, but it wouldn't be paid very much. So kind of not so much point allowing open access there. But over time, as that grows, we'll allow people to register from the community. And then, other teams in the network, I expect, will run their own routers. And then you can have these TEE nodes and ask them to register with multiple different providers. Providers of traffic, essentially. And then they're providing payments in the back end to the node operator. And so that way, you get the sort of best of both worlds. You get this ability to have teams offer a good service to people. Imagine if the Ethereum ecosystem you didn't have to pay or say Solana ecosystem, you didn't have to pay when you were using pump.fun. Right? Like, it's quite annoying that you have to pay gas to to Solana every time. That I'm sure the team at pump.fun would have been perfectly happy to subsidize those. There just wasn't a way to do it that maintained cryptographic verifiability. But basically, this mechanism solves that problem. Alternatively, if people want to, they can just go to one of the open nodes in the system. I think Johnny from our team built this thing called like Eye of
AO. Eye of AO.
Yeah, which tracks a bunch of different nodes. You can even Google for them because they're HTTP servers. You find Hyperbeam nodes by Google. I found out the other day. It's kind of interesting.
Maybe you could use Wuzzy Search. Shout out Wuzzy Search, first permaweb search engine. I'm actually kind of curious because I've been tinkering with nodes myself. What's the pros and cons of a TEE node versus like a non-TEE node? Like, what should I be thinking of if I'm a potential node operator?
Yeah, well, it all comes down to, so AO Core gives you this primitive that allows for the falsifiability of claims about computation of state. It sounds like a mouthful. Let me try and break it down in a way that's... Okay. Basically, it allows people to make claims of truth about the state of a program, right? So you want to know the AO token is a program. You want to know your balance. That's part of the state inside it. AO Core allows you to say, it creates a sort of language, a way of addressing your balance at this particular point in time as part of the tree of all of the program states in the world. And then the node that serves it back to you, if you look in the headers, because the whole thing is sort of layered into HTTP, if you look in the headers, it's providing all of the cryptographic information through AO Core and HTTP signed messages that is required for another node to challenge it, essentially to say, hey, I recomputed that state, and actually I got a different result. And then you can have many different security systems for resolving that conflict. And so if you're inside a TEE, I can look inside those headers from the browser, and I can see, okay, well, it was signed with this address, which I know only exists inside a TEE environment. And then to the level that I trust that TEE, and it's the nature of all TEEs that they basically get broken over time, but they're very expensive to break in the meantime, and even actually sort of afterwards often. So there's some additional barrier. Like the person that would be trying to deceive you there would have to put in a certain amount of capital, and that gives you security to some amount of capital too. Whereas if you run it on your own node, you might want something that's more like a traditional staking and slashing system that says, well, okay, you give back that signed result. Every single result in the system is signed and attests to the values at a specific hash path. And then you can collect up evidence basically from other nodes and take them to a process. It's part of the basic staking system that we're building, where you can say, okay, 5 people, it's simplified, but certain weight of stake and certain set of nodes says that this is incorrect. And then you can stake and slash based on these resolution factors. But by using the addressing system of AO Core, we know how to recompute a specific piece of computation, piece of state in the network. That's like the core mechanism, if you will.
So what is like a mature market? Like, so we've gone forward a year or two in the future. What does the mature compute market look like on AO? Are we talking like thousands of operators with specialized reliability tiers? Like what would the fully fleshed out version of your vision look like?
Actually, the provision of hardware should be proportionate to the demand for, the provision of hardware should be proportionate to the demand for computation. And that's something that really is like profoundly out of whack in existing smart contract ecosystems, even something like Solana that's relatively efficient in comparison to Ethereum, say. You add more computation to the network, it just reproduces the same result over and over again. And you have to look and say, okay, so we have 100,000 nodes in Bitcoin, say, that agree that this block was valid. What is the value of having 100,001? 100,002? It's like exponentially decaying relative to the number of existing validations you have. So you really want computation to be, one, not excessively reproducing the same results, and two, efficiently distributed to the user's demands and matching the level of demand that actually exists. On that side, you said something interesting there, which is, different tiers of security. But that's actually exactly the point for AO token itself. We see it providing an insurance role in the ecosystem. So say you have two parties, they can be processes or they could be just end users, and they want to transact together. So Alice wants to send Bob some tokens, a classic thing. And say they're both processes in this case. When the user triggers this interaction that takes their sort of profile process, something like this on Bazaar, and transfers the tokens to Bob, which is, say, an exchange, then Bob can specify, hey, I'm going to act on this information that you've given me. I want certain levels of guarantees. And this is precisely what AO provides. There are many, at least what we envisage, is many different security systems inside the same overarching verifiable compute framework. And then basically one unifying mechanism that allows people to put collateral behind those claims. So Alice wants to send Bob, a transfer request or withdrawal request from this exchange. The amount is $10,000, say. Then Bob might want, say, $100,000 of insurance on the correctness of that computation. And they would want that for some period of time. They want the exclusive right to claim that stake from the person that pushed the message for Alice in the system. And that's very interesting because it also takes those tokens out of circulation for that period. And this affects token velocity. And so essentially directly makes token velocity proportionate to demand for security, which is how the whole thing glues together over time. So basically you end up burning token time because those tokens have to be put aside as collateral for Bob, in this case, to potentially challenge Alice's claim, or the person pushing the message on behalf of Alice, about the correctness of that compute. And AO Core provides the mechanism through which that claim can be tested.
It's just like how insurance works in the real world. There's no one size fits all insurance.
Exactly. And then if parties want to interact and they have sort of different, let's say, standards even of what is reasonable, they have some sort of collateral, some mutually agreed collateral, and a provider that can custody it for them in the meantime. And that's essentially the role that AO tokens will play.
Okay. Well, Sam, I appreciate it as always. It was great to see you. That was incredibly illuminating deep dive into the transition from legacy net to mainnet and the path forward. Thanks so much.
Awesome. Thanks, Drew.